Today we're going to look at our double angle formulas. I'm giving them here to you on your notes. They're also on your purple sheets, so I'm going to jump right into our lesson. First of all, I just want to remind you the difference between squaring a function and the double angle formulas that we're looking at today. So notice our first one in that left-hand column that is true, that sine squared of x. Remember, we've talked about that is a shortcut for sine times sine. A double angle formula is when you're finding, for example, if you know the sine of 20 degrees and you want to find the sine of 40 degrees, you could use the double angle formula to do that. Starting off, we've got three different types of examples in this lesson. Our first one is given a right triangle, and we're going to use these double angle formulas to find sine of 2x, cosine of 2x, and tangent of 2x. Of course, in order to do that, we will need the hypotenuse. So we'll start off with our Pythagorean theorem. 1 squared plus 5 squared equals c squared, that missing hypotenuse. 1 squared plus 5 squared gives us 26. And the square root of 26 gives us our hypotenuse. Starting off with the formula for sine of 2x, that equals 2 times the sine of x times the cosine of x. Using SOHCAHTOA to substitute those values, we have 2 times opposite over hypotenuse times adjacent over hypotenuse. You do not need to rationalize on these until the very end, because as we're multiplying, those radicals could end up canceling. So don't waste your time doing that in the middle of the problem. In this example, we're going to multiply that 2 times 1 times 5 all in the numerator, and the square root of 26 times the square root of 26 simplifies to 26. Those radicals cancel. So we can simplify our fraction, dividing each by 2. We get our sine of 2x is 5/13. For example B, in order to find secant of 2x, we will first find the cosine of 2x, and then we'll take the reciprocal. If you'll notice, cosine has 3 different formulas. We'll just start with the first one on this example, and we'll look at some of the other ones on different examples in this lesson. So we've got cosine squared minus sine squared. Substituting in those values, cosine again was adjacent over hypotenuse, and sine was opposite over hypotenuse. Squaring each of those fractions, we have 25 over 26 minus 1 over 26, which gives us 24 over 26. Simplifying by dividing each by 2, we get 12/13. So as I mentioned, we'll take the reciprocal of that to get our secant of 2x, which would be 13/12. Finally, we have our tangent of 2x, so we'll use that last formula, which is 2 times the tangent of x, all over 1 minus tangent squared. Substituting in that tangent value, looking back at our triangle, we had 1 over 5, and in the denominator as well. In the numerator, multiplying, we get 2/5. In the denominator, we'll square and then we'll subtract. So we have 2/5 all over 24/25. Dividing fractions, we multiply by the reciprocal. So we have 2/5 times 25/24. And then simplifying before we multiply, I'll cancel the 5 into the 25 and the 2 into the 24. So that leaves me with 5/12 for my tangent of 2x. Our next example, we're going to be given the cosine and the quadrant so that we can figure out the signs on the other trig functions. We're between pi over 2 and pi, so that's our second quadrant. We know our cosine is negative. We were given negative 2/3 for our cosine of x. In the second quadrant, sine will be positive, so we'll find the sine by using Pythagorean theorem again. So we've got that a squared plus b squared equals c squared. Squaring each piece and subtracting, we get a squared is 5, so that missing side is the square root of 5. Setting up our sine of 2x, that will give us 2 times the sine of x times the cosine of x. Substituting in, sine is opposite over hypotenuse. Cosine we were given was that negative 2/3. Multiplying straight across, we get negative 4 square root of 5 all over 9 for our sine of 2x. For cosine of 2x, I'll use the second formula this time. We've got 1 minus 2 sine squared. Substituting in that sine value, which was the square root of 5 over 3. Order of operations, we'll square that before we multiply, so we get 5/9. Multiplying, we get 10/9. Getting a common denominator, we have 9/9 minus 10/9, so that gives us negative 1/9 for our cosine of 2x. And finally, we'll find our tangent of 2x. That formula again is 2 times tangent of x all over 1 minus tangent squared. Substituting in our tangent value, we have the square root of 5 over negative 2, opposite over adjacent. Substituting that in the denominator as well and squaring it. In the numerator, when we multiply, those 2's will cancel, leaving us with just the negative square root of 5. In the denominator, after we square that square root, we'll get 5 over positive 4 once we square that negative 2. Subtracting in the denominator, we would get negative 1/4. And finally, we'll multiply by the reciprocal. So we get negative root 5 times negative 4, which gives us a positive 4 root 5. And our final example, we will look at solving using our double angle formulas. So first of all, we have sine of 2x, so we will expand that using our 2 sine of x cosine of x formula. Then we'll notice we have a GCF of cosine, so we'll factor that out, leaving us with 2 sine of x from our first term, plus, remember, factor means divide. So we've got that cosine divided by cosine, which gives us a 1. The cosine doesn't disappear altogether. Once it's factored, we can set each piece equal to 0. And solve. So we're looking for where is cosine equal to 0. Cosine is the x value on the unit circle, so up at pi over 2 and down at 3 pi over 2. Our second equation, if we subtract 1 and divide by 2, we're looking for where sine is negative 1/2. Using that first quadrant reference angle, sine is positive 1/2 at pi over 6, and it will be negative in the third and fourth quadrants at 7 pi over 6 and 11 pi over 6.